Good morning, students. Dear students, as you know that we are discussing chapter 5, that is laws of motion, and in continuation with this chapter 5 laws of motion, today we are going to deal with part 4. Now, giving the recap of the previous video, I want to show you that we had discussed in the previous video about Newton's second law of motion. Newton's second law of motion. We had defined Newton's second law of motion and gave its mathematical formulation. Then, on the basis of force is equal to rate of change of momentum, we have derived the relation F is equal to ma, and after that we had discussed about some applications based on Newton's second law. Now, before discussing, so students, in the previous video we had discussed about all these things. Now, in the today's video, before discussing Newton's third law of motion, we start our discussion as one of the application of Newton's second law of motion, that is impulse, and in that we will define impulse, one application of Newton's second law, impulse. So, dear students, let's start our discussion with impulse. Impulse. First of all, I want to clear your concept with an example related to impulse. Then we will proceed for the mathematical formulation for the term or quantity impulse. Suppose you all had played the cricket, and in cricket you had seen that the batsman hits the ball. So when the batsman hits the ball, the impact of the ball with the bat is for very short interval of time. But when there is the impact between the bat and ball, then the force is being transferred from the bat to the ball, due to which the ball moves to a certain distance. So whatever the force transferred to the ball for that short interval of time, that force is called as impulse. So what is impulse? We will define impulse: the force transferred to any object for a short interval of time is called impulse. Later on, after deriving the formula for the impulse, we will discuss one or two or three examples regarding this also. So, first of all, what are the types of impulse? Or you can say that impulsive force. Types of impulsive types of impulsive force. What are the different types of impulsive force? So look here students, there are two types of forces you can apply on an object. Then there is a question in your mind, sir, what are the two types, why there are two types of forces and what are the two types of forces? So for that I want to say you students, first time if the force is constant, means if you are applying a force of 5 Newton on an object, then throughout the time interval delta t, that force will be of 5 Newton. But that is called as the constant force, and the impulse or the force transferred to the body for that time interval delta t due to that constant force 5 Newton is impulse due to the constant force. And the second thing is that for that time interval delta t, t1 to t2, due to that, in that time interval the force is going to be varied. For t1 the amount of force is 5 Newton, for t2 the amount of force is 4 Newton, 3 Newton. Means the force is of variable nature. So in that case you will say that the impulse transferred to the body is due to the variable force. So both the type of impulses we will discuss. So the types of impulsive forces, first one is impulse due to a constant force, and the second one is impulse due to a variable impulse due to a variable force. Now students, we will discuss both type of impulses one by one. So yes students, now we will discuss these two topics, that is type of impulses and impulse due to variable forces, impulse due to constant force and impulse due to variable forces, one by one. So first of all we are going to discuss the first topic, that is impulse due to a constant force. So try to understand it. Impulse due to constant force. The first topic, impulse due to constant impulse due to constant force. As we had discussed that before starting of the video, we had discussed that when the force acting on a body is of constant nature for the given time interval. So graphically I want to explain you that. Suppose this is the axis of force, this is the axis of force, and here you have taken the time interval, here you have taken the time interval t. Now the force is of constant, the force is of constant. Suppose this is F average. F average is the force for constant nature, and it is acting on the body for t is equal to 0 to t is equal to t, or you can say that t is equal to t1 to t is equal to t2. It might be 0. What if you are going to suppose here, then time equal to 2 seconds, here 0 second. So in between this area, wherever you can choose the time. So here we have taken t1 and t2. Now, as we have discussed that impulse, first of all we will define impulse. First of all, we will define the force. As you know that force, according to Newton's second law, because this is the application of Newton's second law, according to Newton's second law, that is F is equal to dp upon dt. F equal to dp upon dt. You are knowing that rate of change of momentum, that is rate of change of momentum dp upon dt, it defines about the force. So we can say that F into dt is equal to dp. F into dt is equal to dp. Now look here students, here force is multiplied with differential of time, and here the differential of momentum. And about differential, I had told you, if the time interval or if the change in momentum is very small, then delta b or delta t, if change is very small, then delta t tends to 0 and it can be treated as dt, and delta p tends to 0 and it can be treated as dp. So here we have considered change is very small. Here change is very small. We have written it as dp upon dt. Now integrating both sides, on integrating both, on integrating both sides. So on integrating both sides, because this is for a small time interval, so various time intervals for this comes, if this one is delta t, another delta t is this one, for the same constant force, another delta. So, and it is of continuous nature. So what we will do, we will integrate to get the whole impulse from this point to this. So t is equal to t1 to t is equal to t, and it is equal to f dt. Now from here p1 to p2 dt, p1 to p2 dt, because if force is applied on a body, I had told while discussing about momentum, if force is applied on a body, then mass remains constant because mass is not going to vary. Then it is obvious that its velocity is going to be varied. And if the velocity is going to be varied, then the momentum of the body also going to be changed. So on integrating this, what we will got, suppose this is the average force, and this average force is of constant nature, so it can be taken out. F average dt t1 to t2 is equal to dp, that is p2 upon p. Now dear students, F into dt. So if you are integrating this side, then do integration to this side also. T t1 to t means at time t1 the momentum is p1, at time t2 the momentum is p. Now, and since average force acting on the body is of constant nature, so constant quantities are taken out of the integral. That is integral operator, the constant should be taken out. So now you can write it as force minus V. And this can be written as F average delta T is equal to delta T. Means force delivered for a small interval of time. Force delivered for a small interval of time, that is the impulse, is equal to the change in momentum. Is equal to the change in momentum. So this is the formula for the constant force we have got. Here F average into delta T, force delivered to the body for time interval delta T, and this is called what? This is we had defined as impulse. And this impulse is equal to what? This impulse is delta P. Delta P is what? Change in momentum. Change in momentum. Means clear. From here it is clear, students, that whatever the force you had supplied to an object for a small interval of time or for a given interval of time, that is equal to the change in momentum. And physically also you can understand this. Suppose you are giving a shot to a ball, then mass of the ball is not going to be changed, but due to the application of the ball, the velocity of the ball will change, and since the velocity of the ball will change, then obviously its momentum will change. So it can be interpreted physically also. Now about the unit. Now dear students, we will discuss about unit of impulse. Unit of impulse, and its unit is, as we have discussed about impulse, is F delta T. So it can be written as F delta T. It can be written as Newton second, or since it is equal to change in momentum, so its unit kg meter per second. This is SI unit, or in CGS this is SI unit, and for CGS unit, it is dyne second, or centimeter, gram centimeter per second. Its dimensional formula is the dimensional formula for moment. Dimensional formula. That is the dimensional formula for momentum, and it is equal to m l t minus 1. So it is the dimension of the impulse. Now we had discussed about one of the topic, that is impulse due to constant force. Now we will discuss about impulse due to variable force. Dear students, in the previous discussion, we had discussed about the constant force, and in constant force, we had supposed the force acting on a body is of constant nature. Means if you are applying a 5 Newton force, then for that time interval, that 5 Newton force always acts on the body. But when we are talking about the variable force, then as you know about the variable that with time it is always going to be changes, means it is not of the constant nature. So first of all we will draw about the graph. This is time interval and this is force, and it might be the nature of the graph. Now look at here. At this time interval T1, the force is of F1. If for this time interval T2, the force is of F2. For this time interval, the force is of F3. In similar manner, the force is always going to be changed. The force is always going to be changed. For the time interval, suppose the time interval we had supposed here T1 and here we had supposed T2. Then students, what is the way to find the impulse in this case? What is the way to find the impulse in this case? Can you suggest or you think for that? Yes. Suppose I am taking a small time interval, this is delta t, a small time interval delta t. In throughout the graph I had infinitesimally a small we had suppose the time interval, and for that time interval we had supposed the force is constant. For that time interval we had supposed that the force is constant for that time, only for that time interval, because since it is very small, so we may suppose for that time interval the force is constant. Then what is the force transfer? What is the force transfer for that is small interval of time? That is equal to F into delta t, as we had discussed about the impulse. That is equal to F into delta t. Now, which shape it is looking like? This is the shape of the rectangle. If you mark this rectangle A, B, C, D, then AD is the length and AD is the breadth. AD is the length, then area of rectangle. A, B, C, D, and that area of the rectangle is equal to length into breadth. That is equal to length into breadth, and the length is what? Length is equal to F, and this is the length now, F, that we had supposed the constant, and the time is delta t. Means you can say that for that time interval the impulse transmitted to the body is the area of this rectangle ABCD. Similarly, if someone asks you, you have calculated for a small time interval dt. Now if you have to calculate for the whole period of time for which you had applied the force, then what we will do? We will find the area of the whole curve, area under the whole curve. So, impulse transmitted impulse transmitted for the whole variable variable force is equal to area of the variable FT curve. FT curve means you have to find the area of this, and you have to find the area of this whole thing. Means if you have to calculate the impulse, then you have to integrate it f delta t for time interval t1 to t, and this is equal to area under the curve, area under the curve, you get this curve OE, area under the curve OE, and this is equal to change in moment, change in moment, that is delta. So students, this is all about the impulse. We have discussed today about the impulse due to constant force, impulse due to variable force. Now, one or two numericals we will discuss based on this in the next video, and after that we will continue with the Newton's third law of motion and its certain application, and then we will discuss for next topics. Thank you students. Have a nice day. Take care.